For decades, humanity's relationship with the moon was defined by fleeting visits. The Apollo missions planted flags and collected samples, but our presence was always temporary. Now, a new era is dawning, one focused not just on visiting, but on establishing a permanent human foothold on our celestial neighbor. Two primary contenders are leading this charge to build the first permanent lunar base. On one side stands the United States, spearheading the Artemis Base Camp initiative with a broad international coalition. On the other, the China-Russia-led International Lunar Research Station, or ILRS, presents a formidable alternative. The drive to establish permanent lunar bases stems from a multifaceted vision for humanity's future in space. These motivations span scientific curiosity, technological imperative, resource acquisition, and strategic geopolitical positioning. Each element contributes to the compelling case for a sustained lunar presence. Scientific discovery stands as a paramount motivation. The lunar South Pole in particular has become a focal point due to the confirmed presence of water ice in permanently shadowed craters. This water is not merely a scientific curiosity, it is a critical resource. Water can be processed to yield breathable oxygen for astronauts and hydrogen and oxygen for rocket fuel. This capability would dramatically reduce the cost and complexity of future space missions, enabling deep space travel directly from the moon. Furthermore, water is essential for life support systems, making long-duration habitation feasible. Beyond water, the moon offers a unique laboratory for understanding the early solar system. Its pristine surface preserves billions of years of cosmic history, free from the erosive forces found on Earth. Lunar bases will facilitate unprecedented research into planetary formation and evolution. Technological advancement and survival training also play a crucial role. A lunar base serves as an unparalleled training ground for future missions to Mars and beyond. The moon's harsh environment, with its vacuum, radiation, and extreme temperatures, provides an ideal proving ground for new technologies and operational procedures. Astronauts living and working on the moon will gain invaluable experience in long-duration habitation and self-sufficiency. This preparation is vital for the even more challenging journey to Mars, where resupply missions are far less frequent. The moon becomes a stepping stone, refining our capabilities for interplanetary travel. Resource acquisition represents another powerful incentive. The moon is believed to harbor valuable metals and rare earth minerals, essential for advanced technologies on Earth. While extraction is currently theoretical, a permanent base could pave the way for lunar mining operations. Perhaps the most intriguing resource is helium-3, an isotope rare on Earth but abundant on the moon. Helium-3 is a potential fuel for future nuclear fusion reactors, offering a clean and powerful energy source. Developing the technology to harness this resource could revolutionize global energy production. Finally, geopolitical strategy underpins much of this new lunar race. Establishing a permanent presence on the moon is a clear demonstration of national autonomy and leadership in space. It signifies a nation's technological prowess and its commitment to shaping the future of off-world endeavors. The Artemis Base Camp represents NASA's ambitious vision for a sustainable human presence on the moon. This long-term plan aims to establish a permanent outpost in the early to mid-2030s, marking a new chapter in lunar exploration. The base will be a cornerstone of humanity's return to the moon, fostering scientific research and technological development. The chosen location for the Artemis Base Camp is strategically vital: the lunar South Pole. This region offers unique advantages, primarily continuous access to sunlight for power generation and proximity to permanently shadowed craters. These craters are known to contain significant reserves of water ice, a critical resource for future operations. Key components of the Artemis Base Camp include the Foundation surface habitat. This fixed pressurized living module will serve as the primary residence and laboratory for astronauts. It will provide essential life support, research facilities, and a safe haven from the harsh lunar environment. For surface mobility, the plan includes the Lunar Terrain Vehicle, or LTV. This unpressurized rover will allow astronauts to conduct short-distance excursions for scientific exploration and equipment maintenance. It is designed for agility and efficiency in the rugged lunar landscape. For longer expeditions, a habitable mobility platform is envisioned. This pressurized rover will enable astronauts to travel greater distances and conduct extended research missions away from the main base. It will offer protection from radiation and the vacuum, expanding the operational range of the crew. Power and energy systems are crucial for sustained operations. Initial power will come from advanced solar arrays designed to withstand the lunar dust and extreme temperatures. Looking further ahead, NASA plans to deploy a fission reactor in the 2030s, providing a reliable and abundant power source independent of sunlight. An integral part of the Artemis architecture is the Gateway, an orbital lunar spaceport. This station will serve as a critical transfer point for missions to and from the lunar surface. It will also function as a research platform and a staging area for future deep space missions, enhancing connectivity and operational flexibility. The Artemis timeline outlines a phased approach to achieving these goals. Artemis II, a crewed lunar flyby, is currently projected for 2026. This mission will test the Orion spacecraft and Space Launch System with astronauts aboard, paving the way for future landings. Artemis III aims to achieve the first modern human landing on the Moon, targeting 2028 to 2029. This historic mission will see astronauts return to the lunar surface, including the first woman and person of color. It will mark a significant milestone in humanity's journey back to the Moon. Following these initial missions, the Artemis base camp is projected to become operational around 2033 to 2035. This timeline allows for the gradual deployment and assembly of the various habitat and infrastructure components. The base will then begin its long-term mission of scientific research and resource utilization. Furthermore, Artemis has a clear and well-defined roadmap, outlining specific missions and objectives. This structured approach helps to maintain momentum and focus resources effectively. The program leverages decades of NASA experience in human spaceflight. However, Artemis also faces considerable challenges. Budget fluctuations and political shifts can impact funding and timelines, leading to potential delays. The reliance on private partners, particularly SpaceX for the human landing system, introduces dependencies that could affect the overall schedule. The International Lunar Research Station, or ILRS, represents a collaborative effort led by China and Russia to establish a multi-module scientific base at the lunar South Pole. This ambitious project aims to create a comprehensive lunar outpost, potentially designed for high autonomy and a robotic-first approach. The ILRS seeks to advance scientific understanding and technological capabilities on the Moon. The ILRS concept envisions a combination of surface stations, orbital platforms, communication networks, and habitats. This integrated approach aims to create a robust and versatile research infrastructure. The design emphasizes modularity, allowing for gradual expansion and adaptation over time. The ILRS roadmap is divided into distinct phases, beginning with reconnaissance. Phase 1, spanning from 2021 to 2025, focuses on site selection and technology testing. Robotic missions during this period gather crucial data about potential base locations and validate key operational systems. Phase 2, the construction phase, is planned from 2026 to 2035. This period will see the deployment of foundational infrastructure for the lunar station. It marks a significant step towards establishing a permanent presence on the Moon. Key missions during this construction phase include China's Chang'e 7 and Chang'e 8. Chang'e 7 will focus on detailed exploration of the lunar South Pole, including resource prospecting and environmental monitoring. Chang'e 8 will conduct in-situ resource utilization experiments, testing technologies for extracting and processing lunar materials. During Phase 2, essential components will be deployed, including command centers for base operations and energy stations to provide power. Laboratories for scientific research, landing pads for future missions, And basic astronaut facilities will also be established. The goal is to complete the basic station by 2035. Phase 3, beginning in 2036, is dedicated to the utilization of the fully operational long-term base. At this stage, the ILRS will support extensive scientific research, resource extraction, and technological development. It will serve as a permanent platform for human and robotic exploration. A critical element of the ILRS's long-term energy strategy is China's planned nuclear power station. This advanced power source is projected for deployment between 2035 and 2036. A nuclear reactor would provide consistent and abundant energy, overcoming the limitations of solar power during lunar nights. The ILRS project boasts several significant strengths. China has demonstrated consistent success with its robotic lunar missions, showcasing advanced capabilities in landing, roving, and sample return. This track record provides a strong foundation for future endeavors. However, the ILRS faces its own set of challenges. China has yet to demonstrate human lunar landing capability, a critical step for establishing a crewed base. While their robotic program is robust, human spaceflight to the moon presents unique complexities. The question of who will build the first permanent moon base is complex, with both the United States and China presenting realistic and formidable contenders. Each project, Artemis Base Camp and the International Lunar Research Station, possesses unique strengths and faces distinct challenges. The outcome will depend on a multitude of factors, including technological readiness, sustained funding, and geopolitical stability. Human landing capability is a critical determinant in this race. Both the US and China are actively developing and testing the necessary systems to return humans to the lunar surface. The US, through its Artemis program, aims for a crewed landing by 2028-2029, leveraging its historical experience and advanced private sector partnerships. China is rapidly advancing its own human spaceflight program with ambitious plans for crewed lunar missions in the early 2030s. The infrastructure deployment timelines offer a glimpse into the potential pace of each project. Artemis aims to have its first inhabited base structure operational between 2033 and 2035. This timeline focuses on establishing a foundational habitat for human presence, supported by orbital infrastructure and surface mobility. The emphasis is on a sustainable, long-term human presence. The ILRS, on the other hand, projects the completion of its basic station by 2035, with a fully autonomous scientific station, including nuclear power by 2035-2036. This suggests a potentially more robotic-centric initial deployment, with a strong focus on scientific autonomy and robust energy solutions. The ILRS aims for a comprehensive multi-module research facility. The moon is undergoing a profound transformation, evolving from a distant symbol of human aspiration to a tangible frontier for permanent settlement. This new lunar race signifies a pivotal moment in our history, marking humanity's determined return to our closest celestial neighbor. The ambitions of both the Artemis program and the International Lunar Research Station underscore a shared vision for our future in space. Mining operations will become a reality, extracting valuable resources like water ice, rare earth minerals, and potentially helium-3. These resources are crucial for sustaining lunar operations and fueling future space missions. The moon could become a vital source of materials for Earth and for space-based industries. Fuel depots will emerge, providing critical propellant for spacecraft venturing deeper into the cosmos. By producing rocket fuel on the moon, we can significantly reduce the cost and complexity of deep space travel. The moon will serve as a cosmic gas station, enabling unprecedented exploration. The establishment of permanent lunar bases will have a transformative impact on science and civilization. It will push the boundaries of human ingenuity, fostering innovation in robotics, life support, energy production, and materials science. Our understanding of ourselves and our place in the universe will expand dramatically. This era marks humanity's permanent return to the moon, not just as visitors but as residents. It is a testament to our enduring spirit of exploration and our unwavering drive to expand our horizons. The moon awaits, ready to become the next great chapter in the human story. Like, share, and subscribe. Pulse Nucleum.